Howdy, everyone, and hopefully you've had a productive and enjoyable first day of the hack. So, up now, we've got developer Steve coming and talking about prototyping with tech. So, developer Steve comes from a strong background as a developer with over 20 years industry experience. He has worked with companies, startups, and not-for-profits of all sizes. Developer Steve has worked closely with developer technology communities as a tech evangelist and advocate to develop and nurture the healthy developer and startup culture that continues to flourish. With a passion for sharing knowledge, Developer Steve is an established international speaker and loves geeking out with people everywhere. As a tech evangelist and advocate, he has represented and worked with global companies such as IBM, PayPal, Braintree, Xero, Telstra, Ninx, GitLab, and more. Steve will be speaking about how you can use the low-code/no-code platform to help bring any idea to life. Utilizing IBM Cloud-Free Tier, he will walk through connecting IoT, AI/ML, and many more. And a fun fact, I'm not just referring to him as Developer Steve for fun. It is actually his legal. Welcome, Developer Steve.
Hello, thank you for having me. And yeah, DeveloperSteve is my actual legal name, which we were literally just talking about. So amazing to be here. I hope everyone's building out some amazing stuff. Looking forward to seeing them all. Fun fact also, I'm judging next weekend. So yeah, really keen to see them all and see what everyone's been building out. I've already got my screen shared. Before I get underway, though, I'd like to begin by acknowledging the traditional owners on the lands on which we meet today. I would also like to pay my respects to elders past, present, and future. So I'm not going to go too much into my bio because, yeah, Solomon did an amazing intro. But I am going to tell you the story. So yes, Developer Steve is actually my legal name now. Back in February, I changed it finally. You know, that thing you never quite get around to. I finally got around to filling out the paperwork over Christmas, but Kuchen is my married name. So me and my wife got married a few years ago, combined our last names, created a whole new last name. And well, while my name was in the shop, I figured everyone knows me as Developer Steve. So it's actually my middle name. So my full name's Stephen Developer Steve Kuchen. Anyway, that's the story. So there you go. I love opening workshops and talks with a bit of a developer joke. I do have a whole bunch of these, so please afterwards, if you want to chat, hit me up and I can tell you a few more and get all those face palms happening. But here's the one for today, and it's really important that we keep smiling, especially in times like this. But how do trees check for errors? Via log files. I can feel the face palms already. Roll. So you probably met a few of my colleagues earlier today. Well, I hope you did. So Gloria and Ali did an amazing workshop earlier, but here's the full team. I'm part of this amazing, wacky, zany, fun crew. So we cover the whole, the ANZ region, the Australian-New Zealand region of the world. And yeah, we get to not only work on some amazing projects, but we get to mentor and literally geek out as devs, which is amazing. I'm going to share one of my favorite projects, and this is mega geeky topic. And today we're going to be talking a little bit about IoT. So this is totally in with that. But there's a technique. I also do a lot of 3D printing. So there's a technique known as backscatter Wi-Fi that I got to geek out with a bit with last year. But basically you can create 3D printed objects that'll create Wi-Fi without any batteries or electronics. And as an IoTist, that really blows my mind because the applications for that are massive. Like you think working it into there's a bit of video playing there. Do you imagine like something like this being built into a door hinge so that when the door hinge moves, it basically creates a signal that you can spot from, well, just about anything in range or in the house. Some really cool applications. FYI for the presentations too, I recently discovered that you can drop 3D STL files into PowerPoint and animate them. So there you go. If you wanted to do some 3D animation, the easy way, PowerPoint's your thing. So like I said, we get to work on some really cool projects. One of my other faves that we've done with one of our good clients, Melbourne Water, good friends at Melbourne Water. And this is actually using Node-RED. So, and that's sort of one of the points I wanted to make with this is, what I'm going to show you today, we've used with clients to go full-blown projects from just a prototype. So, the sky's the limit. Actually, probably the universe is the limit because you could go to beyond the sky. But anyway, that's a whole other thing. But essentially, what we used it for with that was detecting blockages in pipes. So, and there's a screen from Node-RED there, but I'm obviously going to show you a whole bunch more of them. But and those little flow, well, those are called flows that you can see there. So, and just like code, like you can have variables that flow through, and you can have information get handled, stored, whatever you need to do with it before a final output. You can see everything really clearly and easily. Won't go into too much of this detail, but essentially from something built out of Node-RED with on a client project, it was literally just a conversation in a meeting saying, hey, wouldn't it be cool if we could do this? So we literally got a Raspberry Pi and some really light sensors and hooked it up, and a full-blown project came out of this, and we're now saving countless hours in the field, needing to repair and do maintenance. Now we can actually predictively tell when something is going to need to be maintained, which is amazing. And again, came out of Node-RED, open source program. Also do a lot of work close with universities. Like this weekend. So yeah, if you have got other events or you're part of an event and there's room for us to be involved, we would love to chat. We do loads of community events. So, and of course, using Remo, as you've all been doing this weekend, we do have a number of layouts, including a brand new one we've just gotten in the last few weeks. It's actually a beach island, but this is one of the other variations of the venue layouts. We've always wanted to run a hackathon on a spaceship, so we did a few months ago. So, which was amazingly cool, and you could almost say out of this world. Yes, there will be more puns. Yeah, that was recently for our Call for Code challenge. So it's actually just finished, so I won't go too much into it. But essentially, first prize is not only 200K, but we work with the project that gets built out. So if you've got some great ideas for next year's global event, would love to chat and see, how we can get you involved. Project Owl from the 2018 global winners recently this year also open sourced. We've worked with them for a couple of years now, and they've recently open sourced their core framework. Essentially, it's a deployable mesh network used for in times of disaster relief. Sorry, just looking at the chat. If anyone has any questions, incidentally, please drop them into the Q&A section or into general chat. So I'll flick back between the deck and the chat from time to time and be able to see what everyone's asking. Anyway, so today I thought it'd be really cool, and this is something, Node-RED is something I love recommending, especially for hackathons, because you are building out that idea, like you're prototyping out sort of an alpha or an MVP version of your idea, just to prove that it would not only work, but to validate it. So, and Node-RED's really cool for this because it is literally drag and drop, but you can actually get down to the code level. It's open source, so you can run it locally. You can run it on IBM Cloud as part of the free tier, which I'll talk about sort of towards the end. But it's really easy to get up and running. There's the GIF. So as you can see there, you literally, just like its name, you have these nodes, and these are essentially JavaScript functions that you can link together to create working programs. And you can do just about anything with it, from hooking up IoT sensors to manipulating data. So one of the projects I've used this for previously was aggregating social media data from any source and then being able to run it through sentiment analysis. So natively, it comes as part of the install. It actually comes installed with ways to connect into some of the IBM Watson services, actually through most platforms, really. The nodes themselves, there's a full open source community behind it. So generally, there's about 2 or 3 options for a lot of the sort of more common cloud platform functionality. So literally drop in an API key into the node configuration, hook up a data flow into it, and then you can add data or manipulate data as you need to with third-party integrations, etc. Developer Alley has just put a getting started with IBM Cloud link into the chat. So, and then, I'll go through a couple options through my talk as well. And again, anyone that has any questions, please just drop them in Q&A or into general. The good thing with Node-RED, and one of the things I really love, particularly with IoT stuff, is it's really easy to get some dashboards up and running fairly quickly and fairly easily. So as you can see there, the dashboard's actually updating in real time as sensor data comes in. So obviously, to get the real time stuff happening, that just depends how much, how quickly you are getting data from your sensors or from your data source to be able to display that. But you can get sort of some really cool real time dashboards happening fairly easily. One of the other things I like is you can also build web interfaces or entire websites using this method as well. So again, you can get stuff up and running really quickly and really easily with little code or near no code. So you can actually write functions inside Node-RED as well, which I'll show you in the demo in a little bit. And you can get as complex as you want. So as you can see there, that is a really complex flow. And possibly some duplication in functionality. But anyway, that just sort of shows that you can do pretty much anything in it, including chatbots, which we're going to take a quick look at today as well. One of the fun projects I've used it for, I bought a coffee table late last year and decided to put 300 neopixels into the coffee table. As you can see there, it's quite a nice effect because it does look like a really big iPad. So, and they're addressable as well, which means I can actually change the individual neopixels in the strings and tell them what 250, 256, 255 colors you can actually make them as well. And all I used was, well, a coffee table, an ESP32, just one of the Wi-Fi DevKit C boards, a string of neopixels. And these are fairly cheap these days, like to pick up. There's still quite a fair bit around. Even Kogan sort of sells ones that you can hook up. The thing to remember when looking at neopixels, totally make sure you get the addressable ones. That way you can change individual lights in the string. MQTT, so those that aren't familiar with MQTT, that's it's almost like the HTTP version, but for IoT devices. So it's a lightweight messaging protocol to go from, that's really handy for these low-powered, low-processor, low-memory devices, being able to connect them into, a server so that you're not getting all the header information that you would normally get with a normal HTTP request. So when your browser opens up a URL, there's a lot of header information that your browser knows what to do with. These little devices, they not only don't know what to do with all the information they will get back, because they're only interested in the body in most cases. It's going to basically take up all the memory on the board just trying to store it, let alone trying to process it. So MQTT, it's been around a number of years now, but it's a very lightweight network protocol. Fun fact too, MQTT was invented by IBM in the late 90s to monitor oil pipeline sensors from space. So they needed a lightweight protocol to pass backwards and forwards between multiple IoT, or not even IoT, multiple sensors on oil monitoring on pipelines, and then be able to talk to them from space. So that's where it came from. And it was open sourced in early 2000s. And of course, we're going to use Node-RED today. Behind the scenes, so how I set that up, and we're going to delve into a slightly different working demo in a bit, but I actually ended up hooking it up to Google Homes. I had a bunch of them around, so I thought, hey, it'd be cool if I could ask Google to make my coffee table change rainbow colors or change red or whatever color it was. For that, I just use if this and that. You can totally use like a cloud function or a Lambda function to be able to do that as well. I was being lazy this day because I just wanted to get up and running and see it working. Either will work fine. In fact, either did work fine. Really basic flow. I know that I could have done the switch a whole lot better in this, but essentially starting from the GH at the very top, that creates an endpoint for the if this and that to send a message to. What I did then was pick up the body of the word. So when I said, hey, G machine, I'm not going to say it because I've still got them set up, even though I am moving at the moment and they're going to hear me and activate. make coffee table green. So the word green would then get passed into this flow via that endpoint. One thing I learned through some debugging, I made it all lowercase, as you can see there, and then it just goes through and does a direct match into a function. So when it does that match, what it's passing out then is a JSON body to make RGB. So it passes through back the color in JSON for RG and B. And then I have a function type, which I then handle on the Arduino side. So a function of 2, for example, would make rainbow lights. So it runs a fancy Arduino function to make all the lights blink different colors at that time. But then if I wanted to make it a particular color, I'm just passing back the RGB in a JSON string. And this was important because if you hard coded the color side of things on the Arduino script, that means to add a new color or make a change, you have to redeploy the firmware. So that moves all the smart side of things over to the server side where I have more control over it. So if I wanted to add a new function or a new color or a particular animation at any time, then it's easier to do it on the server side of things. That then talks to what's an IoT. So once it's got that JSON string response, it's just connecting to the IoT to an IoT broker. So what's an IoT in this case, which is that MQTT connection, and basically drops the JSON string into Q, which is then where the device will pick it up and hey presto, rainbow colors. So today we're going to be looking at an example I originally did. Ooh, let me switch back to the chat. No disco coffee. Today we're going to be looking at a slight variation of this, similar concept, but a couple little different working parts. So this is using Telstra's, this is actually a demo we did recently with good friends at Telstra. So my old stomping ground. They have a really cool, they have 2 really cool IoT networks, which basically give these wonderful little boards some really lightweight connectivity. So the board you see there is a Arduino MKR NB1500. And of course you say, that basically, and you can't see the antenna in shot there, but you can kind of see the cable for it. But essentially, it's a very lightweight mobile network of sorts just for these IoT devices. So they don't have a lot of bandwidth on them, but in a lot of cases, all you're doing is sending like small amounts of JSON backwards and forwards over the network. So for this particular one, there's a shield on top of that board that basically grabs a whole bunch of humidity, weather data, and then passes it back as a JSON string. So how that works, and we'll take a look at the actual flow and code, is I'm triggering using a time-based trigger as soon as the flow starts running. So as soon as it goes, switches on, every 30 seconds, it can that little flow basically connects to the broker and puts the word on into a topic on the broker. On the device side of things, that's then connecting via PubSub, which is a published subscription library inside Arduino. It then connects to the same broker and listens on that particular topic for that on response. So, and again, this is important because I set this up server side so that I can adjust on the server how long before it's wanting a response back from the board. Because on the board side, what we're wanting to do is grab a whole bunch of environmental data, so like temperature, humidity, light, etc., and pass that back to the server so that we can do some funky stuff. Oops, just jumped ahead. Do some funky stuff as part of the response, which we'll look at in a little bit. And then the response back. So once the device sees that on come into that broker topic, it's then going to respond back on a different topic with a JSON string of environmental variables. And again, because I'm triggering it server side, I can adjust the time frequency as to how often that happens. With this demo, what we're doing is we've hooked it up to Telstra Dev's SMS API. So we're able to use the SMS API to send a request in from a user to get the latest temperature, to get the latest environmental stats via an SMS interface. Again, you can do this any way though, like you can have that dashboard where it's gathering data, or even the chatbot where it's referencing the data that you're getting back from your device. So yeah, once the user, and what's really cool about this next bit is this is actually connecting directly to the Telstra Dev API. So it is just a normal REST API call. So with this first part though, the user needs to prompt the response back. So the user's actually sending an SMS in. With the Telstra Dev API, you can set up an endpoint. In this case, I've got /SMS set up as a webhook, so that when a user messages the Telstra Dev API, the response comes in and then it can process it and send a response back with the updated data, which we'll have a look at as well. This second part is sending that response back. So, and for this, it is literally talking directly to the Telstra Dev API just through like a normal REST API call. So it's actually building the response to get a token, getting a token back from the API using API credentials, and then responding back with the updated environmental data. And who's ready for a demo? So I noticed the broker wasn't, let me switch screens. All right, just gonna drop this onto my second screen, like so. There we go. So here's one I prepared earlier. Now my broker is not connected at the moment because my trial, this is literally running on IBM free tier. My trial, oops, I'm just trying to get this working on the other screen. There should normally be, oh, there it is, a little tab. Hey, there we go. So let me get rid of those error messages because I know exactly what they are and I haven't fixed it, which is just lazy me. But okay, also, oh, the broker's down. Yeah, I knew about that. All right, that's gonna keep doing that. No, that's fine. Anyway, I'll switch back off that for now. But as you can see here, like I just stepped through, so I've literally, and for those that aren't familiar with Node-RED, that first node, so these are the list of nodes you can get on the side here. Don't mind my right-clicking randomly. These are the nodes on the side here that you can hook up to create these flows. Most commonly used, or at least the starting point, is this inject node. So this can be used a number of ways, and essentially it's a time-based response back where you can actually set how often it runs and then create some rules around that as well. So, and literally like I just dragged and dropped just then, that is basically how it works. It's pretty cool. And then to connect two nodes together, all you do is just grab two nodes onto the same workspace and then click and drag from one to the other, and that's it. That node's now connected. So essentially what that would do, I should do this in a separate tab actually. Let me create a separate workspace and show you what that looks like. So if I add a new flow here, there we go. My mouse stopped working. Yep, my mouse has stopped working. Amazing. What can go wrong in demos? And okay, there we go. And we're back. So let me do that again, and then I can show you a basic flow. Let's switch this one and just do current flow. There we go. So if I click and drag that again, and we'll inject it once after 1 second, and then every 60, no, we'll do 30 seconds. Actually, we probably don't want to wait that long. We'll do 10 seconds. So do that. And then this is a debug node. So if I double click that one now, I can either get the message payload. So this is just the actual body of the variables that will be passing from one node to another node or through the actual flow itself. I seem to be losing my mouse again. I think it's this screen. Yep, I can't see my mouse. Amazing. No, hang on. All right. Technical difficulties slightly. My mouse is back. Okay, cool. I don't know why it's doing that. Anyway, so if I deploy that now, we should see, yep, there it is, the number coming through, and in about 10 seconds time, we should see it do it again. So it'll just keep dumping variables basically out until we stop it. Yep, there's the next one. So, and that string of numbers there is literally the date time. So, and you can take that and sort of transform it into any date time that you wanted. But this is like normally with these flows, you start off with like something really basic and just sort of keep building on it, like keep adding to the flow until you end up with some amazing, really working flows. So let me delete that one. So switching back to our script there, those errors. Anyway, Let me deploy so it's not doing date time again. There we go. So yeah, this is the first part of that node there, where we're actually triggering the device to send back some data. So it's every 30 seconds, well, 5 seconds when it first starts, and then every 30 seconds as part of the message payload that we're sending to a broker, we're sending the on, just literally just a string on, and then that goes into a what's an IoT broker, but you can also send this to, well, any broker. It's all industry standard. Which I've just set up with some basic API keys here, as you can see. So that's kind of there. These other variables here are all needed on the what's an IoT side. So what they do is determine which device that this is being sent to, rather than it just going to, if you've got a whole bunch of devices connected to the same broker, you only want it to go to the specific ones, either the specific device type or the specific device ID, which you can all configure depending like what you want to call your devices. This is just what I've called it here. And then the command type being sent over, or the topic that it's being sent over to, is trigger. I think I'm getting a message. Let me just switch back. People want to come up to the stage. Can't see anything on the screen. Oh, hang on a sec. Sorry, should have checked the screen sooner. I need to go back through all that now. I think my cable might be loose for my second screen, so sorry about that. Let me step back a bit. You can see now, amazing. Apologies, didn't realize the choice of presenting live. All right, let me switch back to my browser. There it is. Okay, cool. All right, let me go through some of that again. I'll go back through the inject and debug just to show you what that looks like. So going to inject a timestamp into a debug output window, which is what we did earlier. I'll do that real quick now. So this is, wait, let me step back. This is grabbing an inject node and just a debug mode. So what this will do is run a debug out for a date timestamp directly into the debug view, which is, well, this current flow here. So once I click deploy, that'll deploy that flow to start running, and we should start seeing like a string of numbers appear just here on the right-hand side. Any second now. That should have done it by now. Oh, wait. Would help if I turned it on, and 10 seconds. There we go. All right, so let's try that again. So we should see, yep, there's the initial one there. And then in 10 seconds time, which will probably be somewhere in the next 2 seconds, we'll see another string of numbers appear down the side here. There it is there. If you wanted to create an endpoint like I'm doing in the other flow that we're looking at, we'll switch back to in a second, you can do a HTTP in. So what this does is create an external web URL that you can access or be able to send information to, and then you can ingest it and either store it locally or output onto a dashboard. So, and you'd literally just do that by doing something like that, which is what we're about to look at in the next screen in 2 seconds. Yeah, there we go. Got my mouse back. I don't know why it's doing that. Live demos. So, and just to go back through that here, I'm literally doing the same thing here. So every 30 seconds, I'm going to get rid of those arrows. There we go. Every 30 seconds, I'm putting the word on into what's an IoT broker, which is connecting in here. So this is one of the nodes that you get for connecting into a well, the what's an IoT broker. There's a whole bunch of different ways to connect in. Well, as long as it's standard MQTT connection. But the API key you just set up as part of the authentication setup for this node. So then you can just select it as a default connection, which is what's happening here. And then you can output either an event or command. That's a what's an IoT specific option. But and then the device, these details here, basically I can set the device type. So there was a whole series, like about a couple of hundred MKR devices. I can send this one command to all of them, or as I'm doing here, you can just specify one device to be able to send that to. This command type is the broker topic. So trigger is what I'm getting the device to do, basically do exactly the same thing on the device side, which is just connecting to the broker and then subscribing to the trigger topic. And then the format I'm sending through is text because it's just a text on that I'm sending on this side. As you can see there, you can choose a whole bunch of different format types to be able to send. You could just as easily send it as JSON. You could just as easily send it as a number. I just picked the word on. Seemed the simplest way. Once the device gets that information over, and I have I'm going to give you all the GitHub too for this as well. Once I sort of finish picking through this, but the flow, this whole flow is importable as a JSON string. So there's a JSON file stored on the GitHub repo, and the Arduino code's there as well. But I'm happy to talk through that as well if anyone wants after this. So once the device sees that on appear in that topic, then it responds back with a string of JSON variables. And the connection back in is very similar, only instead of posting data over, we're now listening to a different topic. So we're listening to sensor coming back in, sensors the topic, and then the reverse of what we just did to the device puts the data back in, basically sends the JSON string over via the broker, via that topic. We then grab it, which is this store variables here. So what I'm doing here is the response back in will just be a JSON string that we get back in and store as a object, or it's being loaded in as an object. And then using Node-RED's global variable set, we're then storing those in global variables. You can just as easily store in a database. In fact, the original version of this, I had it stored in a cloud database, which is very similar to CouchDB. So just as NoSQL, I basically just took the entire JSON string, and JSON stores amazingly well in NoSQL. The only other thing I'm adding in here, so you can see here, I've got date now. And date now is so that I can work out date now versus date now, updated date, so that I can say how old the data is when the user gets a response back. That's kind of it for the device side of things. The actual API call. So what I'm doing here, I'm using that HTTP node that we looked at a little bit ago. So, and I've got a /SMS endpoint set up. So it's literally just URL /SMS, and then whatever data comes back in, we're able to grab that and do something with it, which is this next part of that flow. So, and I know those that are familiar with the likes of regex, etc., I could have done this a whole lot easier and cleaner using that. I just wanted something that was, well, for a demo purposes, was easy to be able to pick through. So yes, it is a slightly larger if else than I would normally do, but yeah, it was kind of easier. So as you can see here, what I'm doing is I'm grabbing the message.payload, which is the main body transport between flows. You can set whatever you want as to store variables in. So what I'm doing is grabbing the message.payload and moving it to message.sms. So further down the flow, if I want to reference the original response that came back, that comes in from the Telstra Dev API from the user, I still have the original body as part of that transport. The thing to keep in mind with that, though, is you don't want to run out of memory. So don't store too much is basically the short version of that. What I'm then doing is just like the coffee table demo, I'm copying any body that I'm interested in, any part of the body response, to lowercase, because it standardizes and sanitizes the data a little bit, and removing trim just to make sure if the user puts in temp with a space at the end, that we're getting rid of that space, because we're literally going to do a direct match. Again, that would be cleaner and easier with regex if you wanted to go down that path. And from there, once the user sends in the word, we're just going to respond with the global variable and some brief text around it just to give it some context. So if someone SMSs in the word temp, you'll get the temp is, and whatever the global variable is, Celsius. Humidity, pressure, light, UV, etc., etc. If there is no match, my catch-all on this else is to respond with the options that the user can actually respond to. And probably one thing you might have picked up from that design thinking session earlier is it's always important to remember the non-tech users, particularly for builds like this, because They're the ones that potentially won't understand how to interact with your system, your build, whatever you've built out, essentially. So you totally just keep them in mind. And that's kind of what this is for. Like, I don't expect the user to know what word to ask. So if they don't, then I'm going to tell them what they need to be asking for. The last part of the message then is appended as part of the response back is that working out the difference between the two times. So from the data time to now, we're able to work out the number of seconds and round that up a little bit and then add that to the response. So you'll get something like the temp is 20 degrees Celsius. This was, this is last updated, and then the number of seconds since it was last updated. This last part is literally just a formatting to send an SMS back to the user. So this is part of the response that the TelstraDev API is going to want to see. This fancy little thing here is another node you can get from this the sidebar. Essentially what it does is allow you to jump flows. So I didn't want to have lines going everywhere on the screen, so I'm just doing it to jump in the same flow, which you can do as well too. So, but ordinarily these flows at the tabs across the top, you can use that to jump to a completely different flow and then run through a slightly different process. And so that's really handy when you've got sort of more data processing happening from either a user input or user or data sources. Is you can run it through a multiple of flows, store it into databases in one flow, and then have multiple flows go into that. Like, there's a number of ways that you can then start to sort of build that out more. In this case, what I'm doing is that response that we just worked through, that's passing down to this second flow, which is just about talking to the Telstra API and being able to send a response back to the user via their API. First part of that is literally setting the header information. These are my clients, secret and ID, but it's just on their free tier anyway. So for those that don't know, they have their API has 1,000 SMS and MMS for free, which is kind of cool. You can actually get MMS back in as part of your webhook when you register the mobile number, provision it. But the only catch is the images need to be under 2 megs. So you can send MMS out larger than that. But this flow here is literally just talking to their SMS gateway. So I'm setting the API header here. So it's just as post form data. The endpoint that it's hitting, and this is straight from the TelstraDev website, and then the authentication variables that they're expecting to see. So my client ID, client secret, the grant type never changes. It's always just credentials. So that just sets the HTTP parameters to be able to make the API call. And this first part is just about getting a token. So leaving the HTTP in the HTTP request node, leaving those fields blank means that those ones that I just set in that function, it's able to use that to do a call essentially. And then the response back is a JSON response. So the only thing I don't have in this flow that you might notice is I'm not handling any errors in this one. So I totally am expecting it to work all the time. But I'm aware of this. I didn't want to overcomplicate it. It is literally just a lightweight demo. So the JSON that I get back in, converting into an object because it's way easier to handle in this regard. And to validate that I'm getting a token back, I've set up a message flow here. So as you can see there, it's just going to do that debug output again to let me know what it's got back as a response. The only thing we're interested in this first part though, is we're just getting a token to be able to send an SMS. So ideally we just get that token back. And then same thing again, except we're going to use that token to do an actual call. And then we're using that message and the two, which is actually, and you can see here, I've got message.sms out. So that was using the initial data that I got back in. So when a user messages in with that word, like the temperature, humidity, UV, etc., when that comes in, we actually get the user's mobile number that sent the SMS in. We want to be able to keep that number so we can send the response back to them, essentially. Just as another HTTP request, and then a message payload comes back in. So that's kind of it for the flow. I'm going to delete these here. Actually, I'm just going to take them. Yeah, I'm just going to delete them out of here for now, and then deploy. That way, those errors will stop because I don't have a broker running at the moment. I actually don't have the device running at the moment. Just an FYI, I am currently moving house, so I don't have access to all my IT stuff right this second. But I thought it was still cool to talk through sort of the Node-RED side of things. Anyway, but what we can do now is I can send an SMS with my phone, and then you can see the response coming back in. I'm pretty sure the API should be working. Let me turn this message back on. It's disabled. There we go. So what this will do, you'll be able to see the message that I now send in. So I'm just going to fire up to send I'm on my phone right now. So I'm going to send a message in, and then you'll see in the debug, you'll see it come in because of this flow here. So this user SMS in, the webhook will basically send it straight to this endpoint, this SMS endpoint, whatever I send to it. Luckily, I stored the number earlier, as you can probably see on the screen there, and there's no, that's an error message. I thought someone might rush to it and beat me to it. So I'm just going to type in that number, 31, and then I'm going to put the word temp. Should hopefully get a message back in there. There it is there. And you can see there the response I just got in now. So I sent the message temp, in the body temp, and you can see that there. That's my mobile number. Yeah, my mobile number there. And this is the mobile number that I just sent the message to. You do get a whole bunch of other data with this too. Generally, I don't need to use it. It's literally just this message.payload, which has all the good stuff in it. And as you can see there, it's then built a response. So it's gone through that flow in that authenticate, generated an access token, which is that one there, and then use that to send a response back. But yeah, I've run out of free tiers. So you can see that there. Oh, look, people are messaging in now, I think. There's someone else. Hi, DeveloperSteve, which is cool. I agree. So that's kind of Node-RED. There is some really funky stuff you can do with this, and the good thing is there's such a big community around it now on the Node-RED main site that there's a lot of different flows available, plus also nodes as well, which is kind of fun because once you've got that community, like there's so many ideas and things you can do with it. So let me switch back to the deck. There we go. I do love that GIF. All right, I'm going to switch back quickly just to see if there's any questions. Okay, no questions yet. A couple of DMs, but I'll get to those in a minute. So that code there, like I said, we did in conjunction with our good friends at TelstraDev. So Michelle Howie and me both worked on this one. The GitHub we'll post into chat if not already. Let me just check. All right, I'll just grab. I'll update after this and put it into the general chat anyway. But that's the repo. So inside that is the JSON flow that you can import into Node-RED if you want to do something similar to this. And the Arduino code is there as well, plus some steps on how to set all the things up. One of the other things, like I said, there is a way to do this in a chatbot as well. It's an amazing demo that developer Ali did recently. It's actually built off of some code samples we have on developer.ibm.com. There's a whole bunch of interactive like chatbot sample code. There's even agnostically deploying and building out mobile apps. So for our recent call for code, that kind of get you a head start on some of the coding side of things anyway. That's about all I had time for here. But one thing I was going to say, we do run a whole bunch of meetups. We are going to be running one soon, so would love to see folks join. It says Melbourne on there, but I realized recently that the only borders are time zones now. I think there's some 3 a.m. conferences that I'm like, yeah, it's a bit early in the morning. But like we normally run these 6 p.m. Australian Eastern Standard Time, and do all sorts of fun demos with this sort of stuff. So please, if you're interested in geeking out with this sort of thing, then drop by, say hi, come to one of our next meetups. Just going to leave you with one of the things I love telling everyone. Please just use your developer superpowers for good, and of course, be excellent to each other. Now, to end on a real high note, here's a slide with some puppies. Now I'm going to switch back to the screen now. There we go. Oh, and developer Ali, thank you, Ali, has just put the GitHub for the code that we just picked through into the main chat. So yeah, if there's any questions, yeah, let me know. I'm here now. If not, I'll be around for a little bit longer before I need to finish packing. But yeah, if not, then please feel free to hit me up on social media or wherever. Just Google for DeveloperSteve. You'll find me. If not, I'll be around during the weekend, and yeah, really looking forward to seeing what everyone builds out.
Thanks so much for that, DeveloperSteve. That was really appreciated, and best of luck moving house over the next few days. As DeveloperSteve said, make sure you do check any questions that you have in the chat there. Be in and out over the weekend to be able to answer those. But yeah, thank you again so much for your time. That was a pretty awesome thing. I certainly learned quite a bit through that myself. That was fantastic.
No, thank you. I always love geeking out, especially if it's IoT, but it doesn't have to be.
Do take him up on those offers, because I think it's an awesome resource that you guys now have access to, and yeah, make the most of it. Beautiful. All right, we'll leave that one there. Happy hacking, everyone. Cheers.